Hello everyone. In this video here, we're going to talk about every single one of these puzzles that I have in front of us and how they're related to each other, as well as I'll demonstrate a generalized method of solving all of them based on a method of solving the pyraminx. So the first thing I'm going to explain is how these puzzles are related, right? So if you take these puzzles apart, you'll find that their core mechanisms are all the same. They all have a tetrahedral core, which means the core has 4 spokes connected to 4 of the corner or center pieces. Of course, the most common puzzle form with this mechanism is either the cube or the pyraminx. But one might argue that the actual most basic form of this type of puzzle is this one here, which is called the pyraminx. If you compare it to a three-by-three cube, you can see that the distribution of pieces on each face are exact parallels. This one's got 1 centerpiece on each face, 3 corners, and 3 edge pieces. So just like the regular 3x3 cube, but with a triangular face instead of a cubic face. Moreover, when we take a closer look at it, you can see that while we turn a corner on this puzzle, we are always simultaneously turning a face. Like these 2 parts are always moving relative to each other. Then, the total number of pieces on this corner part is actually exactly the same as the number of pieces on this side. We have 1 centerpiece, 3 corners, and 3 edges. On this one, we also have 3 edges, but 1 corner and 3 centers. So this property makes it possible to make puzzles where the 2 layers are shaped exactly the same, like on the cube. I think that in terms of geometry, if I remember correctly, this property that each corner is direct opposite to a face is called a self-dual. So to further demonstrate how these puzzles basically are all shape models of each other and can be so exactly the same, I'll start by solving the simplest one of them, which is the pyraminx in the beginner's layer by layer method, and then extend the method to the remaining forms of this puzzle. I'm not going to go into too much detail on how to solve the pyraminx with the LBL method, and I'm going to just do a relatively quick walkthrough of the steps. So we're going to solve 1 layer, which means that we pick 3 of the corners on one face. I think people call these centers as well, since the turning happened around them. And the common color between these 3 is green, so we flip the green onto the same face, and then we insert the green edge pieces. Like this one will go here, and the yellow green one will go here, and the red green one will go here. And it looks like we've skipped the top layer, so let's just set up a case where it's not skipped. So when we don't skip it, the 3 top layer edges will need to be either permuted or oriented or both. Like in this case, we can see that this edge needs to go here, and it needs to go here, and this is a possible non-skip top layer case. So we do a corresponding algorithm and solve it. So this one is a counterclockwise shift. So we do the clockwise version of the alg, and it solves itself. So if we want to adapt this method to the pyraminx, we first need to find that what types of pieces are not on this one, but on this one. So we can see that it's these center pieces. So after we solve the outer pyraminx part, the center pieces might need to, we might need to do some further moves on them to solve them. So we'll first solve the outer part like a regular pyraminx and solve the centers later. We find 3 corners on the same face, and the common color between them is green. So we move the green side to the same face and then insert the green edges. I actually magnetized this puzzle, but it still doesn't turn out well because the corner cutting is just not there. And this would be a pyraminx layer because we are ignoring the center at this point and solving that until the end. Then we align the top corner to the sides and see how we should permute the top layer edges. We can see that this one also needs to go clockwise to here, and this one go here. So we do the anti-clockwise version of the Sun algorithm, and now they are permuted. So all the edges are in the correct spot, but these two needs to flip. It's blue red instead of red blue, and this one the same thing. So we do the flipping alg, which is a sledge like here, and the sledge on the side. Now we've solved the pyraminx part, but as you can see that we have the centers left. To permute the centers is very easy. There's only one possible case, which is two adjacent swaps. We just do 3 sledgehammers in a row, and we will solve it. So all of these puzzles can be solved with that method, which is just the pyraminx layer by layer method plus a step for the centers. So we can move on to the cube after knowing that. We need to first locate the tetrahedron on the cube. Like if you look at these corners and this one in the back. So what I'm pointing at right now are one of the tetrahedral axes of this cube. So our solve will be focused on turning these corners, and the corners I'm not touching, we'll treat them as centers and solve them in the end. So need to first orient the bottom layer corners. And this one, since white is on top, we want the corner on the bottom layer that has white to also have white facing up. Then orange aligning with this orange. Green is already aligned. Then we insert the bottom layer edges. The yellow one, the red one, and the blue one. The edges don't have orientation on this puzzle as they are all perfectly square and only one corner. So we've actually skipped the top layer again, like these edge pieces are already permuted relative to this center. I will again show just a case that is not permuted. So like this one, we will see that this edge needs to go here because this would be the green face and this would be the orange face. So let them go. I'll just resolve them. Okay, so we've actually solved the pyraminx part of this cube. That sounds funny, I know, but as you can see, we have 3 edges which look like centers from cubes, and then the corners. And of course, this part is missing in the pyraminx. So we need to first swap the center pieces. This one needs to go here, so these two need to swap. We do the triple sledgehammer. And then we also need to orient them. This was not a problem on this one. The centers don't have orientation on this one, but they do on the cube and on some other of these ones back there. I actually have generated algorithms for all the possible center twist cases, but I actually not memorized all of them. I know only one of them, which is the 2-flip. And you can solve all the cases by just using the 2-flip multiple times. So for this one, I'll just pick one that rotates clockwise and do this. So that solves 2 of them. Then the other 2. And it's solved. Next up, we have the mirror cube, which of course is very similar to the cube, but there's only one difference, that these edge pieces actually do have orientation, and they're not perfectly square as you can see here. So I normally start with the smallest corner on top, and then these large corners are what make up the corners of the bottom layer. So with this one on top, the bottom layer corners need to be oriented with the largest face facing upward, kind of like this. And this one also like this with a large face getting upward, and we actually accidentally solved this piece. And then there's this one. So this edge piece will be, I think this goes here. Yes. And then this last one of course goes here. So we solved the bottom layer. The top layer, we can see that I think this largest one, like this one needs to go with the center side that's got the largest face over here. So it's a counterclockwise shift, and we do the clockwise soon, and it's solved. And there's actually one funny thing about this puzzle is that this piece, it looks like almost perfect square, but it's not. Like this part is rounded and this part is not, which means it's actually not oriented yet. It needs to be flipped. And this piece is the perfect square, so we can flip this one together with this one. We just hold these tetrahedral corners and do the flipping out. And now this thing gets flipped. And then we've again solved the pyraminx part. So how should we permute the centers? Like it's easy to identify from the largest one. It always needs to go to the largest slot, which is in here. So we do this thing. And in this case, we only have 2 centers to rotate. This one goes clockwise, put that on top. And then it's solved. So this one looks like a whole mess. So let's first take a look at how it turns. So let's just turn a random side. We can see that this is the top corner. And these pieces that are the same shape but on the side are the top layer centers, which we solved last. And these things, as well as the square, as the top layer edges. This one is called the Fisher skew, by the way. I actually magnetized it, but it still doesn't turn out well. Almost the same thing as this one. So the other layer, the bottom layer, which is where I'm going to start to solve with, has like this center bottom piece, which we are going to solve last, and these bottom corner pieces, which we are going to solve in the start. So if you have actually checked the solved state of this puzzle, you will know that the bottom corners are oriented when they are parallel and facing up. So this one is already oriented, but this one would not be oriented. It needs to be like facing up and parallel. And the other corner in the same layer with these two is this one. It needs to have its white face facing up. And then we can start to insert the relevant edge pieces. We need a blue-red one over here. Then a blue-orange one between these 2 corners. Then the final yellow one. Now we've solved our bottom layer. So we need to permute the top layer edges. We can recognize most easily from this fully white piece. It obviously needs to go to the white side of the top corner. So it's a counterclockwise shift. And we need to do the clockwise soon. And we skipped orientation. None of these edges are flipped. And we go to the center step. So these 2 need to swap. This step is a bit hard to do since we need to turn on these, we need to hold these flat triangle pieces. I'm not messing that up, right? I might mess it up, but I'm gonna just resolve if I did. Actually, I didn't. It's fine. Okay, so then these ones, we've got a 3 center twist situation, which I don't know the one look out. I just do the 2 flip twice. So again, we need to hold on to these bottom corner pieces. The whole point of this puzzle is to be hard to turn. Like, how's that gonna work? So now it's the two swap, the 2 flip. We do this again. second to last, we have this scoop diamond or a 2x2 FTO. So we just turn any random side to look at the pieces. So this is the top corner. These are the top centers. And these corner looking things are actually the edges. So we start from these bottom corner pieces. We need a green white edge piece in there, which is here. Then we need a white gray edge piece, which is kind of like here, right? Yeah. And then a gray green one. All right. Then, so this is the centerpiece that we'll leave until the end. Then, since red is opposite orange, we need to flip these two corners, which are really edges. All right, it's actually skipped, but I'm gonna show you a case where it's not skipped. So like this one would not be skipped, but this actually presents a different difficulty compared to the other one, since it's top corner, like doesn't have any orientation. So we've always been recognizing the permutation of these edges relative to the center, but then the center cannot be used in this case since it's just one color. So the way we do it is that we first align the side colors. And if we have a 2 center swap, it means the corners have been permuted. But if it's a 3 center swap, it means that the corners are not permuted yet. So like here, the corners are not permuted because it's a 3 center swap. So we just move with the 3 center swap layer on top, and we just permute the corners relative to these centers. So we move these 2 red ones clockwise over here. So we do the counterclockwise soon. And also keep in mind that you should turn this layer instead of like this thing, because these are the tetrahedral axes. So we do this one. You can see it's not solved, but it goes into a 2 center swap case. These two. And now it shows that the corners are permuted. We just do the center swap. And it's done. So we also have this guy. You might be wondering, why do we have this? It turns out that the FTO is actually a higher order version of the 4-axis tetrahedral puzzles. It's most closely related to a 5x5 genes pyraminx. And that might be a topic for another video, like solving this one exactly the same as a 5x5 genes pyraminx. But this one shows a scrambled state in the reduced state. So if it only turn 4 non-adjacent faces on the FTO, it becomes a standard tetrahedral puzzle. So we have this top center. So the centers all look a bit like tripods, like these things are part of it. And then we have purple, yellow, and blue. So they go like a tetrahedron like this. So just pick any random face to solve from. Like I know that green is opposite blue, so this face we should first flip the other centers, like this, flip the green side. Then we insert the green edges. This one goes in here easily, this one goes in here, and then this one goes in here. Then we need to orient these edges, which are like really these 3 pieces all together. We do the flip, and then we align the center. Remember that this center exists as a whole, like tripod thing. And then we swap the edges. This one is counterclockwise, this one goes here. So we do the clockwise soon. Again, keep in mind that you turn this solved center side. We do a clockwise soon. And it's solved. So that leaves 2 questions to answer. First is why this method is not actually used in speed solving. So my explanation for that is that when you have more corners on the puzzle that look the same, it makes more sense to finger trick your solutions, taking advantage of all the centers. So it makes sense. It makes sense to like turn on both these things as well as these things when you're solving a skew, for example, and the same for like this thing. But as we already know on the pyraminx, the most methods actually only turn on these corners that are easy to turn. So they very rarely turn on the faces. So one final thing I'm going to add here is that how many layers do these puzzles have? So I've been hearing from some places that if you take a look at the two corners of the pyraminx, they only have one piece in between. So it makes the pyraminx a like one layer puzzle. And like for the cube, each turn turns exactly half of the puzzle. Does that make it a two-layer puzzle? But one can argue from their relation to the Jinx pyraminx that they actually are both three layers. So if you look at the Jinx pyraminx, you turn these two adjacent corners. There are always three pieces in between to turn. And the same argument can be made for turning the faces. Like this face and this face have three pieces in between. On the pyraminx, since the center pieces are missing, it will look like the only thing that you turn is this single edge, but it's really just these center pieces are missing. If you actually look at it from the face turning perspective, so this whole edge line right there actually does have this center edge center. So from this side, it's also a three-layer puzzle. For the cube, it's not much different. When you turn this tetrahedral corner and this tetrahedral corner, there are always three pieces in between. So this can also be argued to be a three-layer puzzle. Alright, so that's for today's video. I hope that gives you guys some insight of how these puzzles really work. So next up, we are probably going to do another on like higher order versions of these things, like the FTO, the Rex cube, as well as the 5x5 Jinx pyraminx.